Hello everyone. Today we are going to present our Attack Kill Chain project. Our team members are Liu Wen'en, Wu Zhekai, Guan Zi'en, and Chen Jungong, and the speaker Wu Zhekai. In this presentation, we will demonstrate a complete cyber attack process following the concept of the cyber kill chain from the attacker's perspective. This project is based on two virtual machines. We use Kali Linux as the attacker machine and Metasploitable 3 running Ubuntu as the victim machine. These two machines are connected through an internal network, which simulates an external website being attacked in a real-world scenario. Starting from this slide, we map our attack process to the MITRE attack framework. First, during the reconnaissance phase, we use T1595.003 wordless scanning, which means scanning the target to collect information, such as open ports and running service. After that, when moving into initial access, we apply T1190, exploit public-facing application, where we take advantage of a vulnerable service that is exposed to the internet. At the beginning, we do not have enough permission on the target system. So in this stage, we use T1068 exploitation for privilege escalation. By exploiting vulnerability in an old version of Ubuntu, we are eventually able to gain root privileges, which give us full control over the target system. Yeah, and after gaining higher privilege, the next goal is persistence. Here we use T1160 as 36.001, creating a local account to create a new super user account on the system. And this allows us to keep access to the target even if the original vulnerability is fixed. And finally, we move to the impact stage of the attack. We apply T1486 data encrypted for impact by encrypting important files on the system. And we also use T1491.002 external defacement to modify the victim website, making the attack clearly visible to the target user. And next, let's talk about the environment setup for this project. In this part, we focus on how the attacker and victim machines are prepared before the attack begins. For our system setup, we use Kali Linux as the attacker machine. The victim machine is Metasploitable 3 running Ubuntu 14.04, which is intentionally designed to contain multiple vulnerabilities. This makes it suitable for practicing and demonstrating real attack techniques in a safe environment. And before launching the attack, we first make sure that both virtual machines are on the same network. And this is quite important because the attacker must be able to reach the victim server. By placing them on the same internal network, we simulate a real-world scenario where an attacker can access a target service over the network. And after setting up the network, we need to make sure that the two machines are actually communicate. So here, we simply use the ping command from Kali Linux to test whether the victim machine is reachable. And once we receive response, we can confirm that the network connection is working correctly. On the victim side, we prepare a folder that contains several important files. As you can see, these files represent sensitive data from a company, such as internal documents or credentials. This setup helps us to demonstrate the real impact of the attack later in the project. And on the attacker side, we mainly rely on built-in command line tools provided by Kali Linux. And tools such as Nmap are used for reconnaissance, and Metasploit framework accessed through MSF console is used for exploitation. We also prepare simple text editors like Vim or Nano to edit scripts when needed. And before moving into the attack process, this section serves as a transition point. We now start to focus on the concept that guides our entire project, which is the cyber kill chain. The cyber kill chain is a model proposed by a US company, and it consists of 7 stages. The attack starts from reconnaissance, where the attacker searches for vulnerabilities. In our project, we use Nmap to scan for vulnerabilities, and we choose Drupal as our main entry point into the system. In the weaponization stage, we use MSF console to prepare a payload needed for the attack. Metasploit help us to package the exploit and deliver it into the vulnerable service. So this step also completes the delivery phase of the cyber kill chain. After delivery, we move on to exploitation. Using Metasploit again, we exploit the target service and successfully obtain access to the system. At this point, we gain a web-based shell, but actually the permissions are still very limited. Since the initial access doesn't give us enough privilege, so we perform another exploitation step here. This allows us to escalate our privilege to super user level. With this, we gain full control over the server and can also create new users for persistent access. And once we have full control over the system, we can finally perform actions on the target. In this project, we focus on two main impacts. One is encrypting important files, and the other is hijacking the external website service. And we made a graph to summarize the entire attack process visually. As you can see, it shows how we move from reconnaissance to exploitation, privilege, escalation, persistence, and finally impact. Now that we have explained the theory and the environment, we are going to move into the actual attack execution part. From this point on, we will follow the cipher kill chain step by step and show how the attack is carried out in practice. The first step of the attack execution is reconnaissance. Before attacking, we need to understand the target system, especially what services are running and what vulnerabilities might exist. Here we use T1595.003 wordless scanning, and our main goal is to collect information about open port. To do this, we use a Kali Linux filling tool called Nmap. By scanning the target IP address, we can see which ports are open and what services are running. From the results, we notice that Apache is running a web service on port 80, which becomes a very promising entry point. Next, we use a normal web browser to check the Apache host website. While browsing the site, we find a folder named Drupal. This immediately catches our attention because Drupal is known to have serious vulnerabilities in older versions. Actually, Drupal version 7.x had a critical SQL injection vulnerability, and this vulnerability was not fixed until version 7.32, which was released in 2014. Before the fix, attackers could easily gain root-level access to the web server. Yeah, and unfortunately for the victim, the target machine is running a very old version, Drupal 7.5, which means the system is still vulnerable. As a result, Drupal becomes our primary entry point for launching further attacks. And to confirm our assumption, we use another Kali Linux tool called SearchSploit. This tool allows us to search for known exploits related to outdated service. After checking the result, we confirm that this Drupal version is indeed vulnerable, which gives us confidence to proceed. Now we move to the initial access stage. Since Drupal is a public facing application and is vulnerable, we apply T1190, exploit public facing application. Our goal here is to gain an initial foothold inside the target system. To make the attack easier, we use Metasploit framework, and as we mentioned before, it is already built into Kali Linux. By opening NSF console, we gain access to a large collection of automatic exploits, and these tools help us efficiently attack the target server. And inside Metasploit, we use the search command to find exploits related to Drupal. After reviewing the results, we select the appropriate exploit module. Once selected, Metasploit can handle most of the attack process automatically. After choosing the exploit, we need to configure it. So we set a parameters such as the target IP address and our local IP address. By using the show option command, we double check that everything is set correctly before launching the attack. We then run the exploit command to start the attack. At first, the exploit fails and does not return a session. After reviewing our setting, we realize that we forgot to specify the correct Drupal path. So we fix it and try again. And this time, the session is successfully created. After obtaining a session, we use the shell command to access the target system. To make the environment easier to work with, we spawn a base shell using this command. And great, now we can directly interact with the target system through the terminal. Yeah, and at this stage, we can browse the user directories on the system. But however, we are still logged in as a low privilege user, which limits what we can do. So to continue the attack and gain long-term control, we need to escalate our privilege and establish persistence. Now that we have access to the system, the next thing we want to think about is persistence. In other words, we don't want to lose access once the system is rebooted or updated. So in this step, we plan to create a new administrator account, which allows us to come back anytime we want. This technique is covered in T1136.001, creating a local account. However, there's a problem here. The account we currently have access to is www data, which has very limited permissions. And with this level of access, we are not allowed to create new user or modify system settings. So before persistence, we must first solve the privilege issue. To deal with this situation, we move on to privilege escalation. We again use Metasploit to help us exploit vulnerabilities in Ubuntu 14.04. And these techniques correspond to T1068, exploitation for privilege escalation. And our goal is very simple. We want to become the root user. Yes, and first we put our current section into the background, then we select a privilege escalation exploit that targets the vulnerable Ubuntu system. And after setting the required options, we launch the exploit and wait for a new section to be created. And finally, we succeed. This time, the new section gives us super user privilege. With root access, we now have full control over the system, which means we can read, modify, or delete almost everything on the server. Now that we are root, we can go back to our original plan. We create a new user account named test and grant it super user privilege. This account looks like a normal user, but in reality, it serves as our backdoor into the system. After creating the new user, we try to log into the victim machine using SSH. And since we already know the IP address and the credentials, this step is very straightforward. And as expected, the SSH login works successfully. At this point, we have achieved long-term access to the system. Even if the original vulnerability is patched, we can still log in using SSH with our backdoor account. This means we now have a stable and persistent control over the victim server, and we are ready to perform the final attack actions. Now we move into the impact stage of the attack. Since we already have command and control access, the first thing we do is target the victim's important data. After searching through the system, we find a folder that contains sensitive files, which represent critical company data. Our plan here is to encrypt all of these files and make them unusable. This technique is known as T1486 data encrypted for impact. To encrypt the files, we use a simple batch script that performs AES-256 encryption. After running the script, all the files inside the folder are locked, and without the correct decryption key, the victim cannot recover any of the data. After encrypting the files, we leave a ransom note inside the same folder. This note informs the victim that their files has been encrypted and explains what they need to do if they want to recover them. This step completes the data encryption attack scenario. Next, we move on another visible impact, website defacement. The victim Drupal website is still under our control, so we decide to modify it. This attack technique is called T1491.002, external defacement. To perform the defacement, we directly edit the index.php file inside the Drupal directory. By doing this, we successfully change the front page of the website to our own content, which can also be used as a ransom message. And this is what it looks like. As you can see here, the website now looks completely different from before. And this shows that the attacker has full control over the server and can freely manipulate public-facing service. Now let's switch perspective. Imagine that you are the victim in this scenario. It starts as a normal day. You log into your Ubuntu system claiming to access some important files or credentials. Suddenly, you realize that all your files are encrypted. You also find a ransom note asking for payment. At this point, you cannot even access your own bank account because your credentials are locked. But that's okay. At least my company website is fine. And you soon check your company website. However, you quickly discover that the Drupal website has also been hacked and defaced. This confirms that the attacker has full control over your entire server. And meanwhile, As the attacker, we are now fully control the victim system. We can access files, service, and the website without any restriction. The attack chain is now complete. And that summarizes what we have done so far. We successfully completed a full cipher attack following the attack kill chain, from reconnaissance all the way to impact. At the beginning, our main goal was to gain root access to the system. During reconnaissance, we found vulnerabilities by simply scanning open ports using Nmap, and eventually we selected Drupal as our main entry point. For the initial access stage, we rely heavily on tools provided by Kali Linux, especially Metasploit. All of the tools are powerful. We still encounter several failures during execution. In this step, the exploit failed to return a section. At first, we were confused and thought the exploit itself was broken. But later, we realized that the issue was caused by an incorrect target URL. After further investigation, we noticed that the default exploit method did not match the target configuration. So we changed the exploit method to better fit the target environment. And looking back, the problem turned out to be a very small mistake, a very dumb mistake. A missing slash in the URL caused the exploit to fail completely. This shows how even tiny errors can stop an attack from working. At first, we thought the exploit or the system was the problem, but in reality, the issue was just a simple configuration error. So this experience told us the importance of careful testing and verification. And after fixing the configuration, we finally obtained a session. However, we still only have limited privilege, so further exploitation was necessary. By exploiting a known Ubuntu vulnerability, we successfully escalated our privilege to root. This step allows us to completely take over the system. In the final stage, we achieved full command and control access. We encrypted important files and hijacked the Drupal website. This completes the action phase of the cyber kill chain. To conclude, these projects demonstrate how a complete cyber attack can be constructed step by step using real-world vulnerabilities. Through these projects, we learned not only the technical details of cyber attacks, but also how dangerous outdated software can be. A single vulnerability, like the one in Drupal, can leave thousands of systems exposed for years. And that's our presentation. Thank you for listening.